Hey guys, this is your next video on electron dot diagrams. If you remember from yesterday, I said there's two models that we use, and this is the second one. So just a couple things to refresh your memory from yesterday. If you printed this paper out, you already have this written down. It's the model that shows the valence electrons of an atom. If you don't have this paper, make sure you write that down. Remember that valence electrons, and we have this note in the square box on the bottom of yesterday's paper, that valence electrons are the number of electrons on the outermost energy level. So when we look at those rings we did yesterday in Bohr's model, the last level that's there is the level that the valence electrons live on. And so that's how you can find them. If you have drawn a Bohr's model, you can look at that last ring, or you can look at the group/family number at the top of the columns that we talked about. There's 18, 1 through 18. And if you remember, one of the exceptions was we don't count the transition metals in those groups for valence electrons. So we subtract 10 from the 13, 14, 15, 16, 17, and 18 column. So we're going to go over that today and do a couple of examples. Okay, so I'm going to give you this example. So if we were talking about hydrogen, you would write the symbol, and so look at your periodic table and write the symbol. And so here's a little screenshot of your periodic table. Hydrogen symbol is H, so you just write H. And then it is in column or group or family number 1. So that means there's one valence electron. Interestingly enough, there's also just one electron period for this one. But like Bohr's model, we always plot the electrons clockwise. So in this one, obviously, there's only one, so we don't have anything else to plot. But you should make that note on your paper so that you know that for when we get to the higher numbers. All right, moving on. We're going to do some practice. Some of this is a review from yesterday. Oh, more practice on these first, though. I forgot. So, F is fluorine. There's fluorine on your periodic table. And we know that if we count these columns, that fluorine is in the 17th group or family. We're going to subtract 10, and that's going to give us 7. So that means there are 7 valence electrons for fluorine. So that means there's 7 electrons on the outer ring. So then we're going to plot those. 1, 2, 3, 4, 5, 6, 7. We went clockwise and we did 7 little dots. Now we're done. Next one we're going to do is boron. Boron is in the 13th column. We're going to subtract 10 away. That gives us 3. So 1, 2, 3. Done. Not very hard, is it? All right, next we have neon. Neon's over there on the far right, kind of smushed. I put a box in orange. And so it's 18. 18 minus 10 is 8. So we got 1, 2, 3, 4, 5, 6, 7, 8. And there's neon. Argon is our next example, which is right under neon. So in the same column as neon. That means it's the same group. It means they have similar characteristics, which also means they have the same number of valence electrons. 3, 4, 5, 6, 7, 8. All right? And that's what that should look like. So I'm going to do one more example with you. All right, so this is a combination from yesterday's work and then today's electron dot diagram. So we have nitrogen, and nitrogen is in the 15th column. And so let's look at nitrogen. There's 7 for the atomic number, so that means there's 7 protons. You're going to subtract the atomic mass, or the atomic number from the atomic mass, and that's going to be 7 from 14 is going to give us 7. And then if there's 7 protons, that means there's 7 electrons, so we have 7. And then we're going to plot this in the Bohr's diagram. P equals 7, neutrons equals 7, 1, 2, 3, 4, 5, 6, 7. So there's your energy levels, 2 in the first, 5 in the second. Looking at your periodic table, to do your dot diagram, you're going to write the symbol, which in this case is N. You saw that on your periodic table. We know that if we look on our charts we just filled out, that there's 5 in the second energy level. You could count them on your Bohr's model. You could look on the written word, or you can look on the fact that it's column 15 minus 10 equals 5. So there's several ways for you to check how many valence electrons there are. So 1, 2, 3, 4, 5. That's what the electron dot diagram should look like for nitrogen. All right, so here, guys, you're going to pause the video when I'm done talking. And what you're going to do is you're going to complete the last 3 and the dot diagrams. Those are the ones that the dot diagrams are for, Al, C, S, and Cl. And you're going to push play to check your work. So push pause now, complete the sheet, okay? Do all of the other 3 Bohr models and the dot diagrams, plus at the top of the paper, the aluminum, carbon, sulfur, and chlorine dot diagrams, and then check yourself. The answers are on here. Okay, so welcome back. Next is magnesium. I'm going to go a lot faster because this is just for you checking your work, so be prepared. So 12 protons, subtract 12 from 24 gives you 12. That's your neutrons. 12 is your electrons. P is 12, N is 12. Put your first energy level in as 2, and then plot the others. There's 8 on your second energy level, and then 2 left over for your third energy level. So that's what your Bohr's model should look like. To do your dot diagram, you got to write the symbol, and then look at the column and see that this is group number 2. So that means there's 2 valence electrons, which means you put the 2 purple dots there. Done and done. Or you could look at your Bohr's model and get them off the last ring there. Next we have silicon, and silicon is right there on your periodic table. Its atomic number is 14, so if there's 14 protons, there's 14 electrons. If you have 14 electrons and you subtract it from 28, you get 14. That's how many neutrons you have. On your Bohr's model, P equals 14, N equals 14. First energy level has 2. Second energy level has 8. And then we count our last 4. To find your dot diagram, you're going to have to look at your columns, subtract 10, 4 valence electrons, and then you're going to write Si and do your 4 dots. And that's what that should look like. You could also count your outermost ring and see there's 4 dots. Okay, hydrogen. This one's sort of tricky on the Bohr's model or on the information collecting part. So let's see, we have hydrogen, H is 1, so there's 1 proton. Normally, you would subtract, well, not normally, you would subtract the atomic number from the atomic mass, and in this case, it's going to give you 0. So there are 0 neutrons in this atom. If there's 1 proton, that means there's 1 electron. So P equals 1, N equals 0. First energy level 1, guess what? Done and done. And then to do your electron dot diagram, you put the symbol as H. Counting our groups, this is group 1. Well, guess what? That means there's only 1 electron. So there's only 1 valence electron. All right. And then we have these 4 dot diagrams. Aluminum's first. Your column or group numbers or family numbers are across the top. 13 minus 10 is 3. Plot your diagram. Boom, done. Carbon is next. 10 minus 14 is 4. Boom, done. 16 minus 10 is 6. 1, 2, 3, 4, 5, 6. Done. Chlorine is in in group/family number 17. 17 minus 10 is 7. So there's 7 valence electrons, so 7. All right. Remember, you should go clockwise, and even on simple ones, when there's 7 and you know you're only leaving one spot open, or there's only 2 and you know where they're going to go, you should always make sure you get in the habit of going clockwise so that you don't ever misplot one when there are more than just a few. All right, if you have any questions, email your teachers. Don't forget to submit both of these papers back into Canvas. Either take a picture or type them out or number a piece of paper and a Word document and submit it back up. Both yesterday's and today's, and then there'll be one more sheet for you to work on tomorrow.